Okay, so let's have another example of summation notation. This would be a different example because we have here your set values of your terms. So given here, we have x sub 1 is equal to 8, x sub 2 is equal to 9, x sub 3 equals 12, x sub 4 equals 15, x sub 5 equals 6, x sub 6 equals 3, x sub 7 equals 10, x sub 8 equals 5, x sub 9 equals 2, and x sub 10 equals 1. So we have here, we have now the corresponding values of your terms. Unlike our previous three examples, the terms that are prescribed are very definite. It is the set of real numbers. While this one, it's different. Let's have to simplify or evaluate the first summation notation. We have the summation of x sub I. We have here a subscript. We have the summation of x sub I as I goes from 1 to 10. That means to say that we have here x sub 1. Your lower limit is 1, then your upper limit is equal to 10. So to simplify this, we simply have to get the total of the given numbers as stated above from 1 to 10. So we have your x sub 1, our x sub 1 is indicated by 8. Plus x sub 2, we have plus 9. Your x sub 3 would be 12. How about your x sub 4? We have 15. How about your x sub 5? We have 6. Then x sub 6, we have 3. Then we have x sub 7, we have 10. Then we have x sub 8, we have 5. Then x sub 9, we have 2. Then finally, we have your upper limit, which is your x sub 10, and it is equal to 1. So that is now the expanded notation of this summation notation. You are simply going to find out the sum from your first term, x sub 1, which is indicated by your lower limit, and you will be ending using your x sub 10. That would be your upper limit. Now we are going to find the sum. 8 plus 9, it is 17. 17 plus 12, it's 29. 29 plus 15, it's equal to 44. 44 plus 6 is 50. 50 plus 3 is 53. 53 plus 10 is equal to, what's the answer? 63. 63 plus 5 is equal to 68. 68 plus 2 plus 1 is equal to 71. So the answer here is equal to 71. That is now the result of this summation notation. Okay, I'll repeat. You simply have to replace your x sub 1 as indicated by your function here, x sub I, wherein your lower limit is equal to 1. So x sub I, that will become your x sub 1. Here it is. So you are going to add 8 plus 9 plus 12 plus 15 plus 6 plus 3 plus 10 plus 5 plus 2 plus 1. So the answer would be equal to 71. Okay, let's go to our second example. We would still be using the same data given above. So here, let us simplify. We have now the summation of 8x sub I as I goes from 1 to 5. So we have here 8 times your x sub 1 is equal to 8. Plus, we have 8 times your x sub 2. It is equal to 9. Plus, 8 times 12. That is known to be your x sub 3. Plus 8 times your x sub 4. That's equal to 15. Plus, then we have your x sub 5, which is equal to 6. So we have 8 times 6. So now, if you are going to find out the answer, just get the product of each of the terms. We have 64, that is 8 times 8, plus 8 times 9, that is 72. Then we have here 8 plus 12, that is 96, plus 8 times 15, that is equal to 120, plus 8 times 6, that's equal to 48. As you can see, your 8 here is not changed simply because it is part of the term. It is a constant. Now, let us find the sum. If you are going to get a total of 64 plus 72 plus 96 plus 120 plus 48, this would be equal to 400. This is now the evaluated summation notation of this sigma notation. The summation of 8x sub I as I goes from 1 to 5 is equal to 400. Okay, thank you.